Okay, you normally would have to find, or not normally, you would have to find the inverse of this matrix, multiply both sides by the inverse, right? So that the inverse and this matrix would kind of cancel each other out, and you would be left with x, y, and q equal to a number and another number. In this case, guys, if you calculate the determinant, right, what's 4 times 3? 12 minus, what's negative 6 times negative 2? 12, so 12 minus 12 is 0. So you would have 1 over 0, which you can't have. Okay, so when that happens, guys, that means that there is actually no solution to this equation. So there is no value of x and value of y that will make these two the two equations that you use to state this up true. Okay? No, it's fine. Just you must have no solution. All right, but you don't have to say determine what is but you must have no solution. No. Okay, are we fine with that one, guys? You did have equations in grade 9, I think, that had no solution. You guys remember if you ended up with like a 0 equals 1, yeah, right? Then you would say, oh, there's no solution. Can't be solved. Then you did matrices exam questions. There are the questions number 1.
And even for us, we did
All right, guys, so they gave you LM and N, 3 matrices, and they asked you to find 2m minus 3n. Remember, if you put a number in front of the matrix, you multiply it in, right? Every term or every element of that matrix, rather, you multiply 2 by that, and it was 3 here as well. Sorry, I'm just going to the question for 2. Yeah, they gave you 3 matrices, L, M, and N. Let me know if anything's wrong there, guys. It's the 9th of September test. All right, for B, they wanted you to explain in words why L has no inverse. And guys, the reason for that is because it's not a square matrix. What is a square matrix again? It has the same number of rows and columns. Okay, so you can add that there if you can't remember. So if I'm saying it's not a square matrix, let me just say square, there's same number of rows. Technically, yeah, because I am still going to teach you how to find the inverse of a 3 by 3. So it's not just because it's not a 2 by 3, but it's not a square matrix. Yeah, no, you can, you just haven't done it. Now, guys, just another thing about these two topics, graph theory and matrices, it's heavy on terminology, right? So we could technically give you like a match-up kind of thing. I won't ask you for definition specifically, but I can do maybe like a, you know, A goes with what, you know what I'm talking about? We have like the table and just match them up. But it's important that you do know the terminology that you are actually able to identify. So like, what is a square matrix? Something that has the same number of rows. For C, explain in words why M has no inverse. So again, guys, M was the same as what we had up here for 5H. M actually had a determinant of 0, so that means that it doesn't have an inverse. Right? Because when you're finding the inverse, remember it's 1 over the determinant, and then we do that whole swap thing. So it's because the determinant of n was 0. And then they ask for the inverse of n. Oh, I see, with integer values for the elements of the matrix. What does that mean, guys? Am I allowed to multiply this 1 over 19 in if they say it has to have integer values in the matrix? No, okay, because what is 1 over 19 times 3? 3 over 19, is that an integer? A whole number? No. Okay? Okay, so they just mean that you have to have whole numbers to do actually. We're not talking about other things. Inverse of n. All right, then you had to do number 6, which was an interesting question. I quite like this question. So for 6, they gave me this matrix equation. I can write it out. I'll just show you quickly. Consider the matrix equation, which is there, right? Which is a matrix multiplied by another one, multiplied by another one equal to M. They asked us to give the dimension of matrix M. So basically the dimension of this product here. Now guys, what are the dimensions of this first one? This is a 1 by 3. That is a 3 by 3. Do we agree? What are you going to get when you do a 1 by 3 times a 3 by 3? A 1 by 3. Okay, so the answer to this product is going to be a 1 by 3, which I'm then multiplying by a 3 by 1, right? Which is going to give me a 1 by 1 in the end. Okay, so that is why my answer for 6A was 1 by 1. That would be the, yeah, those are the dimensions of the answer. And then for B, they asked you to actually calculate the value of K, which was in the two matrices that they had. If M is a zero matrix. So guys, what is a zero matrix? Doesn't matter how many zeros, but every single element has to be a zero. Okay, so a zero matrix. In this case, it was just a 1 by 1, but even if it's like a 6 by 6, right? If all the elements are zero, then that makes it a zero matrix. So zero matrix, all elements are zero. So because the answer M was a 1 by 1, that's why it's just 1, right? 1 row, 1 column, that's 1 element. So guys, I'll just show you quickly. Oh, sorry, let me actually just do this. Okay, let me focus, please, guys. If you multiply these two together, right, you're going to say that product was K times 1, K plus 3 plus 0. Right, you see what I'm doing? K times 1 is K, 1 times 3 is 3, 1 times 0 is 0. So your product of your first row and your first column is going to be K plus 3, right? K plus 3. There we go. That's where that K plus 3 comes from. Okay, then you do your first row, second column. K plus 0 plus 2. Right, so that's K plus 2. Wish I had an extra arm, yes? Yeah, that's very dark in here. Yeah. There we go, K plus 2. That's where that comes from. Last one is first row, third column. K times 0 is 0, okay? 2 plus 1. Do we see where that 3 comes from? Okay, so this is the answer when you multiply the first and second matrices together. You get this. Now we have to multiply this matrix by this matrix. So guys, like I said already, this is a 1 by 3, 1 row but 3 columns, right? And this is a 3 by 1. 3 rows, 1 column. So because these numbers are the same, we can multiply them together. And the answer is going to be a 1 by 1, right? Which is 0. So now guys, if you multiply these together and add them all up, you're supposed to get that number there, which is a 0. Okay, so K plus 3 times K is K squared plus 3K. Are you following? Then if you do K plus 2 times 3, that's going to give you 3K plus 6. Right? And then if you do that product plus 3, the answer should be 0. This is a nice like application type question. Okay, the typical test question. Then it does eventually give you a trinomial if you add all your like terms together. And this you can also write K plus 3, K plus 3. It's fine, same thing. So then the value for K is negative 3. If you got 2 different values for K, that just means that there are 2 different values for K that would work. Right? That would make that original product equal to 0. I think you guys are very bored. I'm not sure if that's because it's just so easy or you just didn't know it. I would rather not know the answer to that question. All right, number 9. For number 9, they gave you 2 matrices. It was P and Q. They asked you first for the determinant, thank you, of Q, which was -8 there. So this was Q, I just wrote it off. Right, so you multiply those two, that's -10 plus 2, hey? So we do that product minus that product. So that was -8.
What is
Then they ask for the trace of Q, which we all remember is when you add the elements of the lead diagonal. So this is the Q. You add those two, right? So 5 plus -2 is 3. With the lines, I think it's fine. Yeah. That's how they asked it in the question. Okay, next up they asked for the matrix product QP. So that was Q and that's P. You're supposed to multiply them together. All right, any questions on C? That's just the matrix multiplication, right? Row by column, row by column. Okay, now guys, the wording in Z was different, but it's something that you need to be able to do. They say determine the matrix R where QR is equal to I. Right? So we have Q, they gave us Q, right? That is Q over there. Now they're asking us what is R if Q times R is equal to I. Now guys, I is the identity matrix. Right? If they're using I anyway, that always means the identity matrix. Which is, remember, all your elements are 0, but the elements in the leading diagonal are all 1. Right? So you can have an identity matrix of any dimension that has to be squared. Right? It has to have the same number of rows and columns. But guys, do we remember what two matrices do you have to multiply together to get the identity matrix? The matrix and its inverse, right? That's the concept that we used in order to do this section, in order to do matrix equations, right? We did this whole thing where is it now? Where we actually calculated the inverse of a matrix so that we could end up getting the identity matrix when we multiply them together. So that's what they're saying, guys. They're actually asking for the inverse of Q, but in a different way, right? Oh, wait, where am I? There we go. So just again, they're asking, what is R so that Q multiplied by R will give you the identity matrix? So R has to be the inverse of Q. That's the only way that if you multiply Q by another matrix that you'll get the identity matrix, if it is the inverse. Okay, 10. Did anyone get as far as 10, guys?
Yeah.
One out of each. Even a little proof thing. Yeah. Alright guys, so for number 10 they said consider the 2 by 2 matrix P. Now what was interesting about number 10 is they didn't actually give you a matrix. They just said it's a 2 by 2 matrix. Alright, and the name of this matrix was give the trace of P if P is the identity matrix. Now guys, if P is the identity matrix, then it looks like this. And they said it's 2 by 2, right? So in A, they're saying, okay, now we're telling you that P is the identity matrix. We already told you that it's 2 by 2. So do we agree that this is P? Right? So what is the trace of this? The elements of the leading diagonal added together, right? 1 plus 1, 2. Right? This would count as like a knowledge question, like a basic question, right? You have to understand, you have to know what is the identity matrix, all right? You need to know what is the trace. And you also need to know that if it's 2 by 2, then this is what it looks like. What if I tell you that P is a 3 by 3 identity matrix? What would it look like then? You would have 1, 0, 0, 0, 1, 0. My bracket isn't big enough, but anyway, forgive me. There we go. What would the trace of that matrix be? 3. There you go. So you need to be able to do a question like this, guys. If I give you information about a matrix and not the actual matrix, right? If I use terminology to describe the matrix, you need to be able to answer questions. For B, what would be? Give the dimension of the product PQ if Q has dimension 2 by 5. So they told us that that P is a 2 by 2, right? Now we're saying we're timing that by Q and Q is a 2 by 5. Can I multiply those two together? Are the middle values the same? Yes. What are the dimensions of the product going to be? 2 by 5. Okay, so again, guys, you need to be able to answer questions without being given the actual matrix. All right, just information about the matrix. For C and D, those are a bit tricky. So I did actually just take values just to check. I had an idea, but then I thought, let me just check my answers. So they were saying, give the determinant of P to the power of T, guys. This is the transpose. I did mention that in class the other day, transpose, which is what? How do you get the transpose? Yeah?
First column.
Yeah, you swap the rows in the columns, right? So you can see here, I just said, okay, let's just choose numbers for P. 1, 2, 3, 4. Right? Whatever. You can choose whatever you want there. 1, 2, 3, 4. This is just to do an actual calculation to see what happens. So guys, in P, if that is the first row, in the transpose matrix of P, that will become the first column. Okay, 1, 2 is going to become 1, 2 like that. You see that? And 3, 4 is going to become 3, 4 like that. Now guys, if we're looking at, remember how do you calculate the determinant? You do this product. And we have the exact same numbers. Okay, 1 times 4. And then you minus that product. Again, we have the exact same numbers. They're just in a different order, but that doesn't matter.
First row in the first column.
Second row becomes second. So guys, the determinants for the 2 by 2 matrix and its transpose will actually be exactly the same number. Right? Because those numbers, yes, they swap rows and columns, but if you're looking at the numbers that you're multiplying, it's actually the same numbers both times. Now this, guys, is something that you're going to have to either memorize or be able to figure out in a test situation. I can ask you this as like a theory question, right? So you need to make sure that if you can't remember or if you can't visualize what happens, make up a matrix P, transpose that matrix, find the determinant of both of them, make a conclusion or draw a conclusion, right? So we see that they have the same determinant. So if the determinant of P was D, it's going to be the determinant of the transpose as well. Right? I'm going to great chats today, guys. Lovely, thanks. For D, this one was a bit more difficult. They asked for the determinant of the inverse of P, again, if the determinant of P was D. So this is what they said. Again, I took my same, like, made up P that I had for the previous question, and I found the inverse, and I looked at what happened. Do we see, guys? -2 and -1/2. I did, yes, so that I could, because this, okay, so the question was saying, give the determinant of the inverse, right? If the determinant of P is D. So we're not looking for the inverse, we're looking for the determinant of the inverse. And in order to find the determinant, you have to multiply that in so that you can do that product and then minus that product. Okay, so that is what I did. I'll never say that. I could definitely think of some interesting ways to ask everything. Okay, any questions on matrices, guys? I'm closing the book on this now, okay? But you know now it's gonna have to be good enough for your test, unless you are please gonna put in for more than All right, graph theory. We are continuing. Okay, is it this one? Yeah, so they asked you what is R so that this is true. Right? So here you can see that they're multiplying Q by a matrix, and the answer is very identical. The only way for that to happen is if you multiply Q actually by its inverse. Because Q multiplied by what is the difference? Q multiplied by its inverse. Okay, so they're actually asking in a roundabout way, they're asking for the inverse. Okay. They didn't say that in the question, but you have to. Yeah. I'm going to post the whole matrix note. I don't know if I'll be able to get it up today, but I'll, yeah, in the next, maybe today, definitely tomorrow, if not today. So then if you may have missed anything, you can go look. Okay, okay, guys, now I don't know how you're going to carry on with your graph theory notes. Sorry, because we had to we had to move away from it, and now we're moving back.